All right. Hello, everyone, and welcome to our Intro to JavaScript GA brought to you by CSO. And don't be intimidated by the fact that we're recording. Feel free to just pipe up with like questions or comments whenever.
Yeah, it's just so we plan to upload this to YouTube later on. I don't think anyone's gonna watch it on there, but it's pretty cool to have. So
All right, so first of all, this is what we're going to talk about. We're going to go over like what JavaScript is, why you might want to learn it because it's really cool, and then we're just going to go over some basic like syntax and how you can do some cool stuff in JavaScript that you might not be able to do in other languages. Because JavaScript is taking over the world. There's this law called like Atwood's law. You know, Jeff Atwood is like the guy who founded Stack Overflow, and he said that like, wait, let me look it up. Yeah, any application that can be written in JavaScript will eventually be written in JavaScript. So, food for thought. All right, so first of all, what is JavaScript? And hopefully this is especially useful for those of you who have like maybe a little bit of C++ or another language experience going over to JavaScript. So JavaScript is a high-level programming language that's mainly used for web programming. And I'd see three main advantages to JavaScript. The first is that it's really easy to learn. You don't have to worry about the details of like how memory is stored in a computer. C++. Okay. It's flexible. Like there's a lot of different ways of doing the same thing, unlike in Python. And finally, it's pretty much everywhere. I think it's currently the most popular language on GitHub. And I think it's going to stay there for a long time. And you can run JavaScript on pretty much any device, even a smart fridge, if you really wanted to. All right, so here's a nice, interesting graphic. It's from the GitHub State of the Octoverse Report 2021. It's like the top languages. So I feel kind of bad for Ruby. Like 2014, they were number 5, and now they're 10. But yeah, JavaScript has been like number 1 the whole time. So definitely something worthwhile. All right, so now let's get into the code. And I think as we go through this, be sure to ask any questions about like stuff that doesn't make sense as we do it. Okay, so first of all, what does a programming language do? By my definition, which is like not really a textbook definition, but this is just what I've experienced. A programming language really just has to store information and process it. And so what we're going to go over in JavaScript is the basic ways of storing information, like variables, objects, and data structures. And then after you store it, then you can figure out how to process it. So here we go. So the first thing you have to know are variables. If most of you have a little bit of programming experience, you've probably encountered variables before. The way a variable works, you just declare var x equals 5. Can you guys see the code?
yeah, I can see it on the right side, right?
Okay, yeah. Good. Awesome. So var x equals 5, and then if I want to access the variable, I can just say console.log x, and then run it, and it'll print out 5. And by the way, console.log is like the way of printing to the console. And oh, I have to open the Zoom chat. Let's see. A data structure is just a stupid programming language. Good one, Prannoy. I like that. Okay, yeah, so variables, you probably have seen variables before, so we don't spend too much time on that. But now what's going on here? Var versus let versus const. So there's actually 3 ways of declaring a variable in JavaScript. You might have seen like let x equals 5 or const x equals 5. Wait, we can't do that because they're all using the same name. The names have to be unique. But anyways, like what's the difference between these 3 things? Pretty much all you have to know is that var is like the old way of doing things until like 5 years ago or something. And then recently they developed let and const. And they're just better in every way pretty much. So I don't know why you would ever use var. So if you want to declare a variable, you either use let or const. Let can be changed and const can't be changed. That's pretty much it. And now data types. I think this is one of the most interesting things about JavaScript and the stuff that people are constantly complaining about. So in JavaScript, it's something called duck typing, which we love here at CSO because we're all about ducks. Like rather than explicitly declaring a type like int x equals 5, no, that's not a thing in JavaScript. We can't do that. Instead, you just say like var x equals 5, and then JavaScript infers that this looks like a number, quacks like a number, so it must be a number. And then anytime you use it later on, like let's say you do whatever x plus y, then it'll infer that both of them are numbers and then do numerical addition to get 10. Oh, someone new is in the waiting room. Okay. Yeah, so JavaScript uses duck typing. So this is the biggest thing to get used to. And there's some weird stuff that happens here. Like if you wanted to, wait, let's say, should 0 equal undefined? I actually don't know what this outputs. Let's see. Okay, 0 does not equal undefined. Wait, should 0 equal 0? Does anyone know? Oh. This is one of the very freaky and weird things about JavaScript. So like if we delete all this stuff and just run this, like for some reason 0 is equal to 0. Because in JavaScript, like it kind of just tries to guess what type you're using, whereas in almost any other language, like 0 is never going to be equal to the character 0 because they're two different things. So JavaScript is weird sometimes. That's why you use 3 equal signs, so it can say false. Anyways, I wanted to spend a little bit more time on that. It takes a while to get used to like duck typing and dynamic typing, but hopefully it'll eventually make sense. All right, so now we've talked about variables and how to store things in them. And then now we're going to talk about my favorite part of JavaScript, which is functions. So functions are a unit of code that accomplishes a task. I mean, in C++, you might have seen like methods, but methods are like part of a class. But in JavaScript, functions don't have to belong to a class. Oh, Pranay sent a nice link to some examples. Yeah, functions don't have to belong to a class. So I can just write a function right here. Because JavaScript is a much less classist language, I would say. So like, if there's this function that just returns like x squared, I can just write it in the body of the file. And then if I want to call it, I can just do something like this. And so here I call the function, I store the output of the function in y, and then I log the output to the console. So there, x, this sign means square, this sign means to the power of, so like x to the power of 2. So it's f of 2. So if you've ever seen math, then you probably know what that does. Oh, but then here's the really cool thing that Pranay suggested that we include. You can actually compose functions in JavaScript. And so you pretty much can't do this in like C++ or Java without like some really, really complicated like class wrappers or whatever. Anyways, so what you can do in JavaScript is you can define a function that takes a function as a parameter. So like, or you already see the example on the left side, but I want to show you a better kind of syntax for defining a function. So this is like a shorthand syntax for defining a function. It's called, I think it's called currying, this technique. So you pass in f to this first function, and then that second function that gets returned, you pass in x to that. And so this is all going over your head. Like it'll make sense eventually once you do enough JavaScript, but like I just want to show you kind of like how cool it can be. And then we just return, let's say h equals some number, and then this is like the definition of a derivative that you get from like cal 1. Something like that. And then that would be able to compute the derivative of f. And so if we wanted to compute the derivative of that function at 2, we could call it like this. And then so this first part would return a function that returns the derivative, and then it would take the value at which you want to compute that derivative. And so this should be what,
you have to
4?
pass the function to it instead of x.
Oh.
Yeah.
You're right. Derivative of f2, yeah. Thank you, Pranay. And so you can see that calculated the derivative. using the definition of a derivative. So, and then I think one last basic thing to cover, loops and conditionals in JavaScript. So what's a good example? Oh, I covered up the old one because true in JavaScript is lowercase. I mean, I feel like everyone has seen a for loop before, but I'll just write one real quick just so you can see it. So this looks pretty similar to Java or C++. For something equals 0, I is less than 10, I++. So just like that. And then you can print out the numbers from 0 to 10, or 0 to 9. Very cool. And I think what that's most useful for is if you wanted to iterate over an array, like 1, 2, 4, 3, 1, or whatever, a bunch of random numbers. And then if you've seen the pattern before, you can just log like the number at each index of the array, just like that. So that's the way you can iterate over an array in JavaScript. And then a conditional is just like an if statement. I mean, I don't even want to spend too much time on this because anyone who's like seen any other language has probably seen an if statement. But like if you just wanted to log the numbers at even indices, then you could say like if I mod 2 equals 0 or something. And then it would just print out like 1, 4, and 1. All right. So any questions so far? Okay. Cool.
Oh wait, that's supposed to be even numbers, right?
Yeah.
Why
Or
is
even
1
indices.
printing? Even indices. Yeah, okay, got it. That makes sense.
Yeah. If you wanted to print even numbers, you could like do that.
Yeah, okay, that makes sense. That makes sense.
On any array. Am I going at a good pace for everyone? Faster, slower? It's good? Okay. Sweet. Now we have an empty page. So let's sit awkwardly in silence for a couple of seconds.
You know, I feel like this part is pretty optional.
Now we're ready to get into some advanced features of JavaScript. So hopefully we can write some stuff that's actually useful. Maybe. All right, so now we're just gonna demonstrate some cool stuff. So object destructuring, rest, and spread operators. These are some new things that JavaScript introduced. So let's say that you have an object. Let's see. So I didn't actually talk about objects explicitly, but I think they're relatively self-explanatory. It's just a group of related properties in JavaScript. Properties and methods, potentially. But we're just going to have properties here. So like a person has a name, an age. What other things does a person have?
Favorite food?
Gender.
Good.
Pineapples on pizza?
And how dare you?
No, it's always set the true because it's good.
I agree.
Mm-hmm.
Amy has taste. Okay. I'm gonna assume that Amy is female. I don't know. Let's say that's the case. And so this is like a person object. And then we can access the person object like this. And so you can see like these are the properties of Amy. But the cool thing is object destructuring. So we can take some of the properties of Amy and then destructure them. So we take each one and then we store like Amy's name into a variable called name, Amy's age into a variable called age. And think about the other way you'd have to do this. You'd have to write const name equals person dot name. Like dot notation is how you access it, like person dot name. And then const age equals person dot age. Const car equals person dot car. What a mess, right? Instead, you can just write one line of code and do all of that. Wow, JavaScript magic. And then, like, just to make sure, if you log the name here, it should have Amy. Wow, it's magic. And then the rest operator is just exactly what it sounds like. It just takes everything else from the object or the array. So it's like other fields here. And then if we printed out other fields, you would see it's everything except for the name, age, and car. So just her favorite food and gender. And then the spread operator is a good way of like copying over an object. And what it does is it just like, yeah, it separates an object into its individual components. So like, let's say I wanted to copy Amy. I wanted to make a copy of Amy. So I can say other person equals ... person. And that will automatically spread it out just as if I typed this stuff exactly. And then let's say I want to add an extra field. Let's say school, TAMS. And so this other person now will have all the properties that Amy has with the school of TAMS. So, why is it so slow? It appears to have broken. Oh, well, now you see like the other person copied over all the fields from person and TAMS. And I think one of the big topics you'll notice, especially in JavaScript compared to other languages, is that like one of the most important things to focus on is immutability. So like you don't want to change objects. Whenever possible, you don't want to change the original object. You want to keep it as is and then make a copy in order to modify it. And so that's what all of these operators allow you to do. So that's kind of a high level thing, but it's, I guess, part of the language philosophy of like most JavaScript users. Okay, and then another cool thing is map and reduce. I think I have an example for this somewhere. Is one of these using, oh, fancy stuff. Here we go. So this is a little bit too stout. Let's make it wider. So let me just take this as an example real quick. Oh, I copied the wrong thing. I was just using a Windows device and like the control key is in a different place from on my Mac. Oh. Hard times. Okay. Yeah. So this is kind of interesting. So it'll take like, this is a way of using the rest operator to take in a bunch of parameters as an array. And then this takes an array and reduce, I don't know if, yeah, I should probably just explain it. So map takes an array and applies a given function to each item to create a new array of the same length. So let's say I had, like, here's an example of how it might be useful. Let's say I had like an array of numbers, but for some reason someone was like weird and decided to store all the numbers as strings. And this actually happens a lot more than you would think. Why am I always using the same numbers? Anyways, 1, 2, 4, 1, and 3. And then let's say you wanted to actually convert them to numbers so that you could do mathematical operations on them. Well, one thing you could do is just write a for loop and then you could just like say that ri equals parse int ri. And then after that, you should get that. Or let me just print out the array before and after so you can see what happens. So that like should convert it from strings to numbers. Cool. But like, what if we don't like writing for loops? Because for loops don't tell you what they actually do. They just kind of like say, we're going to go from 0 to the length, but it doesn't tell you what it actually does. Well, here's a better way.
In fact, in that case, you don't even need the arrow syntax. You could just pass in parse int, I guess, right?
I think, well, actually, not necessarily. Parse int actually takes a second parameter for the radix. So
okay.
If I didn't put that and I just put parse int, then it would pass in the second parameter of map, which is I. So it would like try to parse it in a different base for each index of the array, I think. I've tried it before and it just produces a bunch of really weird numbers.
Okay. That's interesting.
But yeah, for some functions, you can just directly put like the function name. But here, because it'll pass in I as the second parameter of parseInt, you have some problems. Anyways, so, but yeah, that's a good point. So this should do the exact same thing, but now you can see not only has the function shrunk into just one line, but it also tells you exactly what it does. It's like for each element of this array, just call this function and then put that returned value into the new array. And then reduce has a similar advantage in that it's also very clear. It's like you take an array. So map takes an array and then produces an array of the same length. Reduce takes an array and then it produces just one new number or one new value. It doesn't have to be a number. So here, like we do numbers.reduce and then we add the numbers. And what this does is, as you might guess by the name, it sums up the array. So now that we've processed the array into numbers, we might want to calculate the sum. So we can just call sum. Oh, I forgot to explain. This is also another way of defining a function. There's like, or does that make sense, or should I like go through the ways of defining a function again? Anyone?
Yeah, I think it wouldn't hurt to go over that whole arrow syntax thing, I guess.
Okay. Yeah, so let me just go over how to define a function real quick. So I think we all know what a function is, kind of. It's just like a block of code that does something given like certain parameters. But it's like one way you could write a function is like this. Let's just take in an array parameter and then return like something, I don't know. And then another way you could do it is by saying const sum equals function numbers. And yet another way, this is coming back to like what I said about how in JavaScript there's so many different ways to doing the same thing. Another way is with arrow syntax. So you just ditch the function keyword entirely and you just write it like that. So these three things are saying the same. These three statements are like all the same. The only difference is that this function statement is automatically converted into like, or you can think of it as being automatically converted into something like this. And then that means that you can call the sum function from like even before it was actually defined. Anyways, like most style guides will advise you to like just use this style of defining functions or this style so that you don't end up like using the function before you actually defined it in the file. But that's just like a small detail. Anyway, so there's these three different ways and they're all basically the same as each other for all intents and purposes. So like choose what you want. I kind of like this arrow syntax because it's the shortest. All right, so that's that. And you can see that like here, this is like just the shortest way of writing the function. It says take in numbers as the parameters, as an array of parameters, and then call this function and just return the output as the return value of the function. So this is the same as saying like return this value, which is just the sum of the numbers. All right, so hopefully that clears things up about like what a function looks like. Yeah. All right, cool. So now let's say we want the sum of the array. Then we could just call sum of, I think they want it like that. I hope that works. Wow. So what happened? Basically the sum function returns the sum of a bunch of numbers. So like if I wanted to call it with 1, 2, 3, 4, 5, this is that rest operator you saw again. It's like, let's just take all the rest of the parameters and then put it into this array called numbers. So sum 1, 2, 3, 4, 5 returns 15. So that's map and reduce, and that's how like it can turn a bunch of really complicated for loops into just one line. And there's also filter and a whole bunch of others that are also really cool. Yeah, so actually, I'm gonna be honest, like confession, I hardly ever use for loops anymore because of map and reduce. So even though I showed you for loop earlier, like I would recommend trying to use map and reduce whenever possible to work with arrays and even objects sometimes too. Oh, and then another thing that's really big with JavaScript in particular, this is actually something finally that you might not have seen done in other programming languages like C++ or Java, because you don't need to do it as much. But like with web programming, there's a ton of requests that take a lot of time. And that's why like with API calls or database operations, it's slow. And you want a way to like explicitly define how those functions work. And like, should we wait for this function to finish before moving on? Or should we just do these two things at the same time? And so that's what asynchronous programming in JavaScript is. There are three ways of doing that: callbacks, promises, and async await. I feel like I have an example somewhere. Let's see. Oh, it must have gotten deleted. Well, that's unfortunate. Is it in here? Well, given that it is no longer there, I will just demo it real quick. So let's say you have a very slow function. Let's say I'm loading data or something, and then so the typical way of calling it would be like, I might pass in a callback function, and then there's some slow function. Or let's say you take in a parameter. Okay, let's say we're doing that. And I'll explain what that does in a second. Oh. See, even typing this syntax is hard. Don't do this kind of syntax. I'll show you a better way in a second. Okay. So, can someone tell me what you think this code will output? Yes. I hope that's what it outputs. That's what I'm hoping. Let's see if it's right. Yes, you're right, Johnny. It's 11. So the code worked correctly. And so this function here, set timeout, just says like wait for 2 seconds and then do whatever inside here. And then like the classic pattern of, I'm just using the set timeout function as like a stand-in for something that takes a long time. So like you could make an API call that takes 2 seconds, and then after that's done, you would call like the callback function. But like this is really messy because you have to have this like callback. You have to define a whole function just to define what's going to happen after like your slow thing that takes 2 seconds is done running. I mean, some things are even slower and it might take 5 seconds, and then we'll just have to sit here and wait. Okay, it's done. And then, yeah, I don't know. It's just kind of a mess to have to write this. So there's a better way called a promise. This syntax might look a little bit complicated, but usually you don't have to actually write this stuff directly. Because most of the libraries you use to make API calls and stuff, they have promises built in. So we'll just be using the bottom part of the code later. But anyways, we're just going to do the exact same thing. This time we're going to say resolve x plus 5. And this is just a cleaner way of writing the same code as above. So this is like saying we made an API call, and then after we're done, we're just going to return x plus 5. And the API call took 5 seconds. And now let's say we want to call it. Oh, this is going to be a little bit messy because you're not allowed to write asynchronous code in like the body of the main file. So what I'm going to do is, oh, true. You've probably seen very similar syntax in Python. I think Python has like almost the same system. Anyways, I'm going to make what's called an IIFE, an immediately invoked function expression. And what I'm doing here is I define a function, an anonymous function here, that's asynchronous, and then I immediately call it in the main thread, I guess. So this just allows me to write asynchronous code. Let's see, what do I want to do? Const y equals await load data x. Or I have to pass in an actual value. Let's do 10. So just ignore like this stuff because usually you're writing in an async function anyways. But here, since it's like in the main file, I can't do that. And I'll show you modules in a second where you can just write async functions everywhere. But then like this is, there's a syntax error. Can anyone spot the syntax error? Oh, I already declared it. Hopefully this also returns 11. Or wait, 10? It's resolving to, oh, I logged 10. Huh. No wonder it logged 10. But now it should be 15. Yeah, so that's 10 plus 5. So it does the exact same thing, but it uses await to wait for the promise to finish running, and then you console.log the results of that. So the cool thing about JavaScript and also Python is that it lets you like explicitly just say, wait for whatever this thing is to finish and then store it in here and then do the rest of it. Rather than having to pass in weird like callback functions and stuff like that. So, and asynchronous programming is actually a little bit hard to wrap your head around, especially at first. But it's really common in web programming, so you'll be forced to do it a ton if you ever write any JavaScript. So I think you'll probably figure it out. Okay. Yeah, so modules. I like modules. So the cool thing about modules is they're encapsulated, like, they're a way of encapsulating functionality into well-defined units. So you can just make a file that's a module, and it'll contain a bunch of functions. Like this one contains a function greeting, or this one contains like 2 functions, sum and multiplicative sum. And what this allows you to do is that in your main file, you don't have to worry about like the details of how any of that is implemented. You can just import, let's see, what's this file called? Math.js. So I might import math from the path of the file relative to the project root. And then if I want to use those functions, I can just call it like that. So you can see here, I define the default export, and then there are the functions sum and multiplicative sum. And when I define a default export, this is how I import it. Oh, I forgot the from. Import math from this file. And so this imports the default export from this file. And the default export contains sum and multiplicative sum. And then now if I want to call it, I can just call the function like this. So, wow, 1 plus 2 plus 3 plus 4. It's kind of weird seeing stuff run immediately now. You don't have to wait for like 10 seconds. Asynchronous programming is weird. But yeah, so that's a module. And the cool thing is that I don't have to worry about how math is implemented. I can just call the functions from the module. And so in any sort of larger scale project, you're going to want to use modules as a system for like dividing up what your code does into smaller pieces so that each one has to focus on less things. It's just a good design principle to keep in mind. Maybe we can also import greeting, just for fun. Let's say we want to greet. How does the greeting function work? There's supposed to be code intelligence for this. Name is forgot. Hello, Pernoi. Or also functions so that you can pass in different languages too. I think there's also Chinese. Wow. So, anyways, and I don't have to worry about any of the internationalization code or translation because I just need to call the function from the module. And it was exported like this. So that's a module. And then a class. I mean, I feel like everyone has seen a class before because pretty much everyone, like if you took CS 1030? Yeah, 1030 or 1040, like they talked about classes. It's like, oh, class animal. And then animal has like, the syntax is slightly different. It might take in like a name and then this dot name equals name. And then the way you use it is just like something like that. And then so let's make a getter as well, just so you can see how this works. It should output rover, I hope. Yeah. So hopefully everyone's seen a class before. You can also do like class dog extends animal if you wanted to, or I mean typical class stuff. It's the syntax is slightly different, and the main reason is that JavaScript classes are not actually classes. It's actually like compiled. It's like converted into functions at runtime, so that like when you run the function, it actually converts this class syntax into like a function animal. Anyways, like JavaScript classes are actually pretty complicated. I mostly stick to functions, but it's based on like prototype inheritance, which is kind of hard to wrap your head around. And I don't completely understand it yet either, but I think it's very powerful if you do understand it. So maybe you can get into it. Oh, and then this is my favorite part of JavaScript. I said it was functions. That's my favorite part of the language, but this is my favorite part of like the whole ecosystem.
By the way, there's a question in the chat.
Oh, you don't need to declare the variables before the constructor. No, you don't. Let me see if I can get that back. Yeah. So in JavaScript, this comes back to the whole like duck typing or like dynamic typing thing. You don't need to explicitly define like what properties an animal has, but you will say in the constructor like what belongs to the this object. You don't need to explicitly define like what the class has, I guess, which sometimes causes a lot of problems. And so we'll talk about TypeScript a little bit later on, and TypeScript solves that problem. But yeah, not declaring the variables before the constructor is actually kind of like not good, because then you don't know what the class actually contains. Anyways, so JavaScript is weird like that. All right, NPM. We're about to see some pretty colors. So here's how you use NPM. NPM hosts every package you'll ever need. Yeah, you just NPM install chalk. And then that's a lot of output. Oh wait, why did I run it from the console? I don't know if it actually works when you run it from the console, but I'll run it from the shell. And then so, yeah, just in your terminal, you write npm install. Yeah, npm is just like pip in Python. So it allows you to install modules that other people already made and then import them. So now if I wanted to use chalk, I just import chalk from chalk. And by the way, there's like an npm registry. So you look up like chalk npm, there's this website npmjs.com that is on the slides here. So like this is all the documentation for chalk. It's open source, so you can go and fix it if you find something broken, but usually the most common ones work pretty well. So chalk, we want to do console.log chalk.blue. So I don't know, pick a color. What color do we want to use? I'll just do yellow first. So you can just run this and then, wow, that doesn't look like yellow.
It's like orange.
Wait, that's definitely orange. Hold up. Anyways, let's just ignore the fact that that's definitely not yellow.
Purple
try
probably
blue.
has their own coloring. Oh yeah.
Ah, I don't know why yellow is not yellow. Oh, purple is not a function, so apparently purple doesn't exist. But
Oh.
maybe red exists. Wow. Anyone else want to try color?
Wait, what is orange?
That's a great question.
Because yellow is orange. Oh,
Oh,
orange is not a function. Oh, you can actually define like, anyways. You can define like what color you want it to be, but let's try green. So
Yeah, and then somebody else in chat asked for maroon.
Oh, I don't know about that one. I don't know if they'll have it. Let's see. Oh, maroon is not a function. Yin blue.
For some reason, I doubt it.
Okay. Anyways, maybe we should just stick to green. And then I think in the documentation there's like a way to just use RGB and underline. So let's try that. So if we want this RGB and underline, we can use it like that. And whoa, fancy text in the console. Yeah, and so like you wouldn't want to write all of that code by yourself. So instead you can just install it or import it, install and import it from npm. So the cool thing is that people have made so many cool packages to cover so many things you would need to do in JavaScript. Just like with Python and even Java and PHP, they all have their own package managers, but JavaScript has one of the best ecosystems just because so many people use it for so many different things. Right. I think this is the last slide. This is for advanced users, but not really, because everyone needs to care about code quality. Especially when you write big projects, you want to make sure your code doesn't break. And one of the biggest things people attack about JavaScript is kind of like what Andrew brought up. Like you don't have to declare what properties a class has explicitly. You don't have to like declare what type a variable is explicitly. And so stuff gets really, really weird when you, for example, compare like 0 to 0. And I don't know, a lot of stuff goes wrong. And that's why we have TypeScript, which is a version of JavaScript with type checking built in. I don't know if we can go all the way back. This graph here, do you see TypeScript right there? TypeScript is actually a version of JavaScript. It's like a wrapper around JavaScript that enforces type checking. What that means is when you define a type in TypeScript, like, I mean, this file, REPL only lets me write JavaScript, but the way you would do it in TypeScript is like X, and then you might say it's a number. And this way, if I tried to assign X to like hello, TypeScript wouldn't let me do that because it's not a number, that's a string. And so that would make TypeScript work much more just like Java or C++ in being like statically typed. It's not actually statically typed, but it makes sure that you don't do like weird sketchy stuff with your types, with your data types. And types are actually such a big problem in JavaScript that like a lot of people actually have started using TypeScript because it fixes those problems. So if you see this graph, TypeScript was invented in 2012 by Microsoft, and then since then it's just taken off. Look at it. It's like rank 4 out of all the languages on GitHub now. Pretty impressive. It has overtaken C#, PHP, C.
Yeah, it also makes you wonder, like, I mean, just how far of a lead JavaScript has on everyone. Like, given that, I mean, if you combine JavaScript and TypeScript together, like, I don't know, just like that number must be even larger than what they currently have.
Yeah, exactly. And TypeScript is actually fully interoperable with JavaScript, which means that like any JavaScript file is a valid TypeScript file, which means that like they're really very, very similar, like much more similar than like C and I don't know if they're more similar than C and C++ actually. Maybe they're analogous to C and C++. Or no. They're more similar, I would say, because C++ has new features, right? Yes, Java is to JavaScript as car is to carpet. That's pretty accurate.
What's interesting, I would say, actually, one thing is because people keep bringing up Python, it's that Python has something similar to this. It's to TypeScript. They have there's like a library that basically lets you have like type hints and stuff, which then you can run like a program that sees if the types are kept together forever or like kept the same for the time being. But like it goes to show that how like dynamic typing and not giving the type of a function or something is actually like really overrated in a programming language unless you are using it for a small script. I would say for like every big project, it just causes problems.
This is very true. Yeah, like for a project I'm working on, I just switched over to TypeScript because it was getting too big and unmanageable for JavaScript. Because like when the project becomes so big, like you no longer remember the code that you wrote yourself, and when you have to guess like the type of everything, it just becomes way too confusing. So yeah, Pranoy is very correct there, and all of the other people who are using TypeScript. But like JavaScript's good for small things too, and it works on a large scale. You just have to be careful. And then the other things I wanted to talk about: code style, ESLint helps to enforce your correct code style. Just make sure that you let's check out this style guide actually. This is my favorite style guide. Airbnb wrote like a guide to how to write good JavaScript code. I would recommend a read, whether you're experienced in JavaScript or like just getting started, like at least some of this will be relevant to you because they have a lot of good advice. There's so many ways to do everything in JavaScript that like it's important to know what like the best ways are. Yeah, this is from Airbnb. So I can send the link in chat. The Airbnb, the company. They actually have a style guide for React too, and Ruby. There's only 3 major JavaScript style guides. There's one called like the standard style guide. There's the Google style guide, and then there's the Airbnb style guide. So take your pick. I kind of like Airbnb, but that's just me. Maybe.
I like standard, but parts of it are garbage, so it's all in the air.
Yeah, I don't know. Code style, it's like you don't want to worry about it, which is why you have a style guide to kind of tell you what to do, so you don't have to think about it.
Exactly, and then ESLint, so like that's really helpful in my opinion.
ESLint can automatically tell you your code style, like when you need to fix it. It's just like Grammarly, but for code, pretty much.
Yeah, and
Yeah.
If I remember correctly, there's also like an option that you could have to like for it to like automatically fix certain style things that are like small things, like oh you forgot a semicolon or something. Although in JavaScript you don't actually have to have semicolons, so there's that.
Yeah, you don't have to have semicolons. Oh yeah, so for anyone from C++ or Java who hates semicolons, JavaScript doesn't require semicolons.
No,
Yeah.
please write semicolons.
It's entirely optional.
Please use them. Please use them because automatic semicolon insertion is what JavaScript does to divide up statements, and sometimes it does like really weird things. So just use semicolons, but you don't have to. And also testing libraries. JavaScript has a lot of testing libraries because so many people use it. This is mostly for like larger scale projects probably, but like they allow you to make sure that like all of your assumptions about your code are correct and to make sure that the new changes you make don't break anything that you already made. So these are just a couple, Jest, Mocha, Cypress, but there are a lot more. I've only used Jest, so that's the only one I could possibly talk about. All right, so now what's next? This is like the stuff you can do with JavaScript now. I mean, you can pretty much do anything. But this is like the last slide, I think. So we can kind of just, right, let's see, is there stuff after this? There's an empty slide. Let's stay on this slide, it's more interesting. So pretty much you can do anything. So first of all, you could just play around with stuff on like replit.com. Oh, it's just called replit, not repl.it. Replit.com, you can just write code there, play around with it just like we were just doing. You could try making a website. JavaScript's the standard language for the web, so like anything you write on the web, you should use JavaScript. You should be using JavaScript, or you can use something else, but JavaScript is the standard. Web server code, like if you're writing an API, I mean any kind of web app, JavaScript works really well for that. And then you could try some leak code problems, which are good practice problems for programming interviews. And then, or you could just work on your smart fridge, because apparently JavaScript is supported on smart fridges now. So hopefully that was a good, I think we're almost out of time. So hopefully that was a good overview of like what JavaScript does, how it works, and then why you might want to learn it. And I think it's really a green field. Like JavaScript has a lot of potential, especially with TypeScript coming up. And it's a good language to learn if you want to get into any kind of industry, like web app programming. JavaScript is pretty important for almost all of that stuff. So thanks for coming. I think I'll stop screen sharing so we can just talk about stuff.
In that case, I will stop the recording.